Alright, so this is part 2 of angled projectiles. This is a completely different, so this is our second example. So cannon in this one is sitting on top of a cliff that's 60 meters high. It is launched 53 degrees with a speed of 25 meters per second. The cannonball lies 90 meters away. And we want to know how long was it in the air and what was the maximum height that it achieved. So there's lots of different ways that we can solve this problem. I'll show you a couple of different ones, but again, angled projectile problems, step 1, always find v naught x and v naught y. So let's just make sure we've got our givens here and they're correct before we do any calculations. Got a nice diagram here, cannonball off the top of a cliff, 60 meters high, 90 meters away. And we've got all of our givens. Notice that dy is negative because we've gone down from where we initially were, as well as ay and ax are there. So everything seems in order. So let's draw a diagram. Let's just draw a triangle for vy, not for vy, to get v naught y and v naught x. So we've got v naught here, and we've got v naught x and v naught y, and our angle theta. So in this one, we'll get v naught x is v naught. We are adjacent to our angle, so we're cosine of theta, which means v naught y will be v naught sine theta. So 25.0 meters per second, cosine of 53.0 degrees, and that gives us 15.045 meters per second to 3 sig figs, and 25.0 meters per second sine 53.0 degrees. That'll give us 19.9659 meters per second, again to 3 sig figs. Okay, A, how long was the cannonball in the air? Let's look at A. So we're looking for time. You always have a choice to make in terms of looking at the vertical values or the horizontal. As you're still learning, you won't necessarily know which one to go to first. So try both, see if you have enough information. In the vertical direction, we know dy, we know v naught y, we know ay, so there's 3 things. So we should be able to do this. The equation that we'd have to use would be dy equals v naught yt plus 1/2 ayt squared. Nothing is there in 0, so we can't rearrange it the same way. Because of that t squared, this is a quadratic equation, just like you would see in math. So what you can do is if you bring the dy, so everything's on the same side of the equation, so you get this 0 equals, and I'm just going to rearrange it so that it's t squared plus v naught t minus dy, because we brought it over from the other side. That should hopefully look like a standard form quadratic equation, and then you could use the quadratic formula. That sounds hard. Don't want to do that if we don't have to. Let's take a look at our horizontal. Only equation we can use, again, horizontal, constant velocity all the time. Only equation we have is dx equals vxt. That is a d. Okay, do we have dx? Yes, we do. Do we have vx? Yes, we do, because it's constant the entire time. So let's rearrange for time, and we can see, and we can get an answer. And dx is 90.0 meters over 15.045 meters per second, and that will give us 5.98 seconds. So there we go. That is a lot easier than using the quadratic formula, but you have to be able to see that you can use the horizontal values. If you use the vertical, not a problem. And for B, we are looking again for what is the maximum height the cannonball reaches. So we are looking for dy max. Remember, Vy at this point will be 0 meters per second. So we have to use that to our advantage. We want an equation with Vy, V naught y, Ay, and dy. Your go-to whenever you don't have time, because we don't know how long it takes to get to that middle point. We only know how long it gets to the ground, which is not the same as, it's not symmetrical, so we don't know the time up equals the time down. So we have to not use time, so we end up with using our Vy squared equation. And we're looking for dy, so dy equals Vy squared minus V naught y squared over 2ay. Okay, plug everything in. So this is 0 meters per second. Square that minus 19.9659 meters per second. Square that all over 2 times negative 9.80 meters per second squared, and that will give you 20.34 meters to 3 sig figs in our answer for dy. But that's not going to be our final answer because we're looking for the maximum height. The cannonball was launched from 60 meters. This is our displacement from launch, which was 60 meters high. So our actual height above ground would be dy, so dy max would be equal to dy plus 60.0 meters, which will give us a final answer of 80.3 meters for dy max. So always make sure you're answering the question. So maximum height was over here, which is this total height. Make sure you're taking a look at all the details of the questions. That's a second example. So take a look at the quiz problems, challenge yourself to some of the questions of the textbook, and we'll spend a lot of time going over problems in class because these ones are really important to be able to do, and they're really interesting because there's cannonballs, and we can play with our trebuchet that we have as well, so we can throw golf balls around the soccer field. Alright, we'll see you in class, and physics is awesome.